Before we get into too much detail, we need an overview of the different sorts of pigments that we're going to be looking at. And I'm quoting from the Integrated Iridology textbook on page 204, which says, "The principle of less is more applies when considering the possible influence of pigments." Pigments are random flecks of colour throughout the iris, and they range in colour from brown, yellow, orange, and black. Iridologists also have called them psora or freckles. Joseph Deck referred to them as chromatic signs, and the Felke Institute used the word chromatosis to describe discoloration in the iris. Inherent pigments allude to organ weakness associated with family history. And how do you know if it's an inherited pigment? You ask whether they have had any issues in the area personally, and if they haven't, we will assume that this is a transgenerational pigment. So in this instance, it means that they're occurring in an area that's connected to familial health issues. And this is my granddaughter. I just showed you in the previous section how she has developed this pigment on the gallbladder region. However, pigments have been observed to develop after exposure to noxious chemicals or physical injury. And this is a client who said that they got these pigments when they went away for the war. It's an old man, and he had to take quinine to prevent malaria, and the quinine discoloured his iris. And of course, these are now part of his tapestry, if you like. He now has these as a permanent feature in his eyes. Another reason why you get pigments developing is in the case of an injury where it was severe enough to require maybe heavy sedation or some other drug medication. This was a fractured femur. You can see that it's just above the knee, and obviously they had pain medication. They were in a cast for 6 weeks and so on. There was ongoing pain that was then treated with pain relief, and she has developed a pigment. And when you see not many pigments and they occur in primary areas of the skeletal structure, always inquire about whether those bones have been broken or if there's any major injury in that site. Perifocal pigments can flag an area of interest, and the colour determines the significance. So here we've got an orange pigment in the pancreas region. So that's topostable. The orange is produced by the organ where it occurs. So this person was born with a lacuna in the pancreas area, indicating that there is the possibility of pancreas issues in his family. It's the right eye, so we would question the eye parent's family history, so the father's family history. And the fact that he's now got orange pigment on that region, this is now something that he is experiencing himself. So a lacuna simply says, I'm related to someone who's had issues in their pancreas. But when you get a pigmentation, this means that it's now been activated in his case. So he has an active problem with the pancreas. We also have perifocal pigments that can mean activation of a pathological potential. So in this case, we have a lacuna. It's a lancet lacuna. It's got a brightened border and it has a pigment. So this acts like a flag to an iridologist, and we need to make inquiries. This is in the area of the thyroid, and in this case, that person did have a thyroid pathology. Pathological disturbances are primarily confined to single small examples of pigments. So we said less is more. Why has this person only got one pigment? Why is it in this area? And we'll be looking at her case history at the end of this subject. One thing we used to learn in the Jensen system, that when a person had multiple signs, we analysed each and every one of them. But the Europeans discovered that when you have many of one sign, so for in this case, many pigments, it reduces the individual significance of each of those pigments. So they become less significant when there are more of them. And one of the things that they did learn is that multiple random pigments are a biomarker of hormonal disturbances and a disposition to hypoglycemia. It has been my clinical experience that when you see multiple random pigments, regardless of their colour, these people usually have a very well developed sweet tooth. So to summarise, consider your iris to be your personal tapestry. We start life with a particular pattern and colour, and throughout our lifetime we will be exposed to various liquids, solids, gases, toxins and experiences. And this exposure combines to add to the tapestry that is our iris. Our choices in life produce different colours in our eyes. Thus, your iris reflects the unique person you are. For example, we know that it's not in our best interests to smoke, but many people smoke anyway. And it's interesting that when you look at a smoker, you may notice that they have orange stains on their fingers. Do you think that their lungs internally would also be stained? Well, you might be interested to know that the sinus area is situated between 5 minutes to and 5 minutes past 12 o'clock space in the humeral region. And yes, smokers can develop pigmentation throughout this area. So when they smoke chronically, and it might be passive smoking, as in the case of this person, they can develop pigmentation in this region. And so, as we were saying, going back to my theory about the tapestry, when you buy a tapestry template, you'll get a guide and it tells you where to put each colour so that you end up with the same colourway that you see on the cover of the box. And in life, we know things that we should do or should avoid to have ultimate health and be the best version of us possible. Sometimes we make choices that are not ideal, and so we change the colour that was originally going to be there. So just a little point to remember, that we can do anything we like, but we have to accept the consequences of our choices. So pigment in the iris can tell us something important by telling us where to look, and it can also identify areas of special interest. The colour of the pigment in the iris determines which organ is exerting an influence on the area in which you find it. So we know that yellow indicates the kidneys, orange indicates the pancreas, and all shades of brown and black indicate the liver. Topolabile is a term referring to pigments produced by one organ exerting an influence on another area. For example, you might observe an orange pigment in the ovarian area. This is interpreted as the pancreas, the producer of orange pigment, influencing ovarian function. So try to see the connection between the organ that produces the colour and the area where you see the colour. So in this example, you might expect mood swings or a sweet tooth during ovulation. We've got orange pigment throughout the eye, but if this was just the one pigment, here it is on the uterus, we're thinking in terms of the female reproductive cycle and what kind of influence could the pancreas have on that person and when would it be most likely to occur. So can you see the picture that I'm drawing and the way that I'm using the information to figure this out? Going over it again, we did say size matters. So just one tiny pigment like this is more important than a multitude of pigments. Research has indicated that less is more. And going back to this solitary pigment, the European authorities have said that a pathological crisis is only seen in connection with small pigments. I actually don't agree with that. I've seen pathologies where the pigments have been multiple and where they have been larger, but it is very significant when an iris only produces one pigment, and particularly if it's black. And we look too at pigments as activation signs. So any pigment attached to a lacuna, as it is here, a transversal, a tophi, or any other sign can indicate activation of the disposition. For example, a pigmented tophi is much more likely to indicate alteration to breast tissue than a non-pigmented tophi. So in this example, we see not only is this lacuna pigmented, it also has a brightened border. And this is in the area of the thyroid. So my questions will definitely focus on thyroid health in this instance.